I'm Justine Murphy with Vision Systems Design's Focus on Vision. There are a lot of exciting things happening in machine vision and imaging. Let's take a look. Industries like automotive and aerospace must adhere to very precise geometries when it comes to manufactured components. Spotting errors in those components, however, isn't always easy. But new 3D technology could change that. Researchers at New Mexico-based Los Alamos National Lab have developed a 3D system comprising AI, laser scanning, and coordinate measuring techniques to identify dimensional errors in manufactured parts. Called Intelligent Rapid and Optimized Dimensional Inspection, the new system centers around AI-enabled software, Maestro, which generates predictions regarding measurement errors in the contours of manufactured parts. A laser scanner attached to a robotic arm scans high-risk areas before Maestro combines 3D scanning data with other data on inspection points, like those generated via coordinate measuring machines. All of the data is then evaluated against original CAD specifications. The 3D system is very versatile, the team says, with the ability to work in both additive and subtractive manufacturing processes, inspect finished parts and those in process, and operate inline or offline. The team plans to test and validate the software in full-scale implementation with the help of commercial partners. A new inspection system should allow stronger, more effective production of steel and nickel-based alloys, in turn potentially offering a manufacturing boost to the aviation, automotive, and gas and oil industries. A team of researchers from the AIT Austrian Institute of Technology and Voestalpine Böhler Edelstahl, a German manufacturer of steel and nickel-based alloys, have developed an approach for inspecting billets, a form of raw purified metal that's used in steel production processes. As billets are rolled into final products, it's crucial that they remain free of surface defects, like slag inclusions or cracks, which can expand during further production, ultimately creating significant flaws in the final products. The new system uses inline computational imaging, a process that combines photometry, which measures light in the human-sensitive visible spectral region, and light field imaging, which uses images from different viewing angles. AI software is also involved to identify cracks or other flaws in the billets. The team says their system is now being tested via a pilot program at Voestalpine Böhler Edelstahl. RealSense, an AI-powered computer vision technology developer, is now on its own, armed with $50 million in Series A funding. The company, a spin-off of Intel Corporation, specializes in 3D depth camera, including for LiDAR, and vision technology that's used in autonomous mobile robots, access control, industrial automation, and healthcare. And following the recently awarded funding, RealSense has unveiled its first new product, the D555 PoE camera, an AI-enabled Power over Ethernet stereoscopic camera. It's essentially a 3D imaging approach in which images of a scene are taken from multiple angles and then used to recreate 3D depth information. RealSense officials say they are continuing with their product development roadmap, including opportunities to combine 3D vision with AI for edge applications. That's it for this edition of Focus on Vision. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit vision-systems.com for the most up-to-date, interesting, and exciting news impacting the machine vision and imaging industry.